Welcome everyone on our weekly learning sessions. For those who are for the very first time with us, I want to give a quick overview about our weekly learning sessions. These sessions are hosted almost on every Friday and are done by delivery services team from Parity. During that session, we provide some overview. We teach about at least one frame pallet or one substrate tooling. My name is Daniel, and today with Alexander and Pawan, we are going to talk about executive pallet. The agenda for today. So at first, I'm gonna give you some overview about the executive pallet. So I will cover the main purpose of the pallet, then I will tell you about high-level features of executive pallet. Then we will talk about dependencies with other frame pallets and other libraries. And at the end of my presentation, I will show you how executive pallet is used in Substrate and Polkadot and Kusama ecosystem. Then Alex is gonna show you executive pallet demo. And after that demo, we will have our first Q&A session. During that Q&A session, you can ask us questions about, pallet overview, about demo, and any other stuff that you want to. For people who are interested more in technical details, Pawan is going to provide some code walkthrough and explanation for the executive pallet. Executive pallet main purpose. Before I describe the main purpose of the pallet, I need to point out that our frame pallets are kind of divided into two groups. The first one is about functional business pallet that provides business functionalities to our runtime. I mean pallets providing some assets management, your currency transfers, stuff like that. And also we have some core pallets that provide some functionalities, structs, any types for another pallets, and also for blockchain operation. Executive pallet is a type of a core pallet, so it not provide any business logic. It provides some kind of orchestration module for the whole runtime. So it is responsible for triggering multiple operations during block execution. To be more strict, let's talk about the operations triggered and managed by the executive pallet. The first operation is transaction validation. To repeat myself, executive pallet only triggers and manages the validation. It doesn't have any logic. It just triggers. The whole logic is in another space. So while checking transaction, basically it checks whether a transaction would panic or not when included in the block. And basically it doesn't include any state changes. Another operation that is managed and triggered by the executive pallet is block initialization function. During that operation, there are some block headers checked, operations like checking parent header, stuff like that. And also, during block initialization, executive pallet triggers on initialize hook on every pallet from our runtime. Let me tell you something more about it. Basically, when you implement any pallet, you have a possibility to run your own code on a specific time of block creation. And the example of that time of block creation is while a block is initialized. So we have onInitialize hook that is triggered by the executive pallet while block initialization. And that hooks are triggered per each pallet from our runtime. Another operation managed and triggered by the executive pallet is all extrinsic processing. I mean, applying the whole state changes, stuff like that, and making the whole changes saved. Another operation is, the whole block execution, starting from block initialization, extrinsic execution, and block finalization. During block finalization, we have final checks, for example, of state root or extrinsic root in our block header, but also here, executive pallet triggers another 2 hooks from every pallet from our runtime. These hooks are on idle and on finalize. At that time, I need to point out that block finalization here, it is not the same as block finality in a consensus. This is not consensus, this is only about block creation. So please don't mix that terms. Besides the whole block execution stuff, executive pallet provides us a possibility to add our own custom logic to runtime upgrades. So every time when we upgrade runtime in our blockchain, we can add additional functionality, and this is the space for adding it. Besides our functionality, at that time every time when runtime gets upgraded, executive pallet also triggers another hook from our pallets, and that hook is called onRuntime upgrade. The last step managed by executive pallet are off-chain workers. And what are off-chain workers? For people who are not familiarized with that term, I'm gonna give quick overview about off-chain workers, but you need to know that off-chain workers are a very broad topic, and this is enough material for another learning session. And for sure, we will have that learning session in the future. Okay, so imagine a situation when you implement your own pallet and you need to do some extensive computation. For example, you need to call an external service via HTTP, like Oracle. You need to do some encryption, decryption on any other extensive CPU computation. Maybe you can exceed block execution time. So to avoid that situation, off-chain workers are prepared. So any computation done by the off-chain worker is not included in a blockchain. To give more overview, off-chain workers have their own WASM execution environment and are outside of the Substrate runtime. When we want to specify some logic for off-chain worker, we need to write that logic inside a pallet so that off-chain worker can easily access our blockchain state, but in order to change or modify blockchain state, off-chain worker needs to send a transaction to our blockchain. There is no other way to modify a blockchain state from off-chain worker. Let's talk about dependencies with other frame pallets and libraries. At first, I need to provide some overview about pallet coupling. We have two ways for pallet aggregation. So imagine a situation that you write your own pallet and you need to use some external pallet. The first option is to directly specify the call from a pallet just by providing the pallet name, and that type is called tightly coupling. The second option is to define some kind of behavior that needs to be executed in our pallet. And in our pallet, we don't care who delivers the implementation of that behavior. We only know that there is a behavior and we use that behavior. And we don't know in pallet's code who will run it. And this is called loosely coupling. So our executive pallet only depends on system module, the frame system pallet, and here we have tightly coupling. So when you check the code of frame system pallet, you will find direct calls to the frame system pallets. There are no other dependencies. But as I mentioned you previously, executive pallet is responsible for triggering multiple hooks from every pallet from our runtime. This is done with all pallets with system tuple. This is some kind of list with all pallets from our runtime specified, and that list is generated in construct runtime macro. The last thing to cover from myself is usage of executive pallet in Substrate, Polkadot, and Kusama ecosystem. Basically, pallet executive is the default orchestration module for Substrate nodes or parachain nodes. So when we want to use executive pallet as an orchestration, we need to provide some details to the pallet. I mean, something like block type or who will validate unsigned transaction. Technical details will be covered by Pawan during the code walkthrough. And once specifying the details for our orchestration module, our executive pallet, we need to provide some API implementation for our runtime. And you can see on the screenshots that that we need to specify how orchestration module will trigger, for example, off-chain workers, how it will trigger block execution, block finalization, stuff like that. This is all from my palette overview. Now it is time for Alexander's demo.
Thank you, Daniel. Now, straight to the demo. As Daniel already told, this executive palette is actually very unordinary, and normally there's not much that you can do about it, but still, let's try to show something that is possible to do with the palette. And for the very first scenario that can be done with the executive, actually, as you can see on my screen, this is the guy that I'm talking about. So let's start with something really simple. Since this palette is responsible for the block execution workflow. Let's tweak that workflow a little bit and add some extra logic to one of the stages. And for the sake of this demo, let's go with something as simple as adding logs. So let's decorate our guy. Okay. So the stage I'm gonna tweak is initialize block. So I'll just copy paste it from here and put the logging functionality that I was talking about. This one, just to make it like more visible. Okay. And let's see how it actually looks like. I'm using Substrate node template, which is publicly available on GitHub to play with it. So I'm starting a node right now, and here we can see our messages. So we just tweaked the init block stage a little. I'll leave it running here because we'll need the running node for next example. And for the next example, it's a little bit harder one. So let's imagine a situation when we have a simple proof of existence pallet on a chain. I've already implemented this one. It is a very simple one, consists of a single storage that stores the claims and a single extrinsic is responsible for creating these claims. And like originally, we were storing like, let's say, contracts. So like a type of document, a contract. We were storing some contracts on the chain, and then we decided to add another type of document, let's say a certificate, and we've come up with, but instead of like changing anything in the palette, we decided to instantiate another. Sorry. Do you know how to do that? Not that simple. Doesn't work. Is it really bad, or is it like seeable? How bad is it? Uh, uh, I never did that, honestly. Sorry, Control Plus doesn't work. I tried it already. I mean, it was my first guess. Uh, uh, no, it doesn't work. Or it might be. Yeah. Oh, it's Shift. Okay. Is it better? Just probably increase a little bit more. Is it okay now? Okay. No problem. Yeah, I had it pre-compiled, just not to waste time because compilation is time consuming. I just didn't want to waste our time. So yeah, it was pre-compiled. Yeah. Okay. So currently we have 2 instances of our proof of existence palette. One for contracts, one for certificates. And then we just figured out that this solution, this design doesn't work for us, and we want to try a different approach. You know, and so we decided to implement a palette that is capable of storing multiple document types. And yeah, I did it as well. Here's the storage for it. So instead of having a unit type, we now have a document type in here. And the next thing we want to do now, of course, first is to add it to the runtime. And the next thing is that we want to migrate the claims that already exist on the chain to a new pallet. And for this purpose, we will use our executive frame, executive pallet. We'll put a migration in here, and a little bit later, I'll explain how it works. So it looks like this. The migration is defined in a new palette documents. Here you can see it. And from this palette point of view, migration is that it simply understands that it needs to create new documents, and that's it. It doesn't make any decision on what to do with the previous claims. And this approach like let us to keep our responsibilities separate, which is kind of good. So we just get the documents. So this like kind of a dependency is injected here. We get the documents that we want to create, iterate over them, and insert into a corresponding storage. And the main decision on what to do with the previous claims actually is taken here in the composition root. So when we are injecting this kind of a decision here we're in the runtime, we are implementing it. And in my case, I decided, to get all the claims from 2 previous instances and remove them. So, but actually, decision might be different. But in case we want to make a different decision, the only place where we will be changing our code is exactly this place, which is kind of good. And yeah, also that's basically it. Now let's see how it looks in action. I created a simple front end to show what it looks like. Okay, I won't be compiling. I also have already the runtime precompiled, so to get things to make it quicker. So we are currently on the first version of the runtime. So no documents are in here. Let's create a couple of contracts. It will appear in here. So here's this contract. Let's create one more. And one certificate. Okay, now we have 2 contracts and 1 certificate. And the next thing we're gonna do is to update the runtime. upgrade runtime, and we'll see how it happened in real time. Just a second, I need to wait while it's updating. And we have moved our claims to a new pallet. And basically, that's it. What I wanted to show.
Thanks, Alexander. Thanks, Daniel, for the information about this executive palette. So, all right. So, here in this piece of like slides, like what we are doing here, well, we'll be directly going into the code, like we'll be deep diving into the source code, and we'll see how the flow is, going, how the things are flowing in under the hood. So, firstly, this executive module, if we talk about these information we already looked into in the Daniel's slides. Like these are the functionality which it provides: a check validity, transaction validity, initializer block, apply extensives, execute block, finalize start of chain worker, right? So this actually here the implementation part, this executive module provides the following implementation: the executive block, which is actually a trait, and the type, like this is the executive type, right, which we'll be defining in the runtime. And obviously Daniel and Alexander already showed you guys like how we are defining the executive palette. Now what we are seeing here, how things are flowing under the hood. If we talk about the flows, so let's start from the beginning, like execute block, right? So we'll go from the execute block, and we'll see how things are going under the hood, right? Okay, so this is our execute block function, which contains all the flow. Like initially we are initializing the block, right? Then we will do initial checks, then we'll do signature badging, along with that, like verifying the signature, final checks, and execute the extrinsics. Now let's see how it is happening in the execute block. What it is, initially what we are doing, we are just initializing the tracing, and we are just using this within span macro for the tracing purpose only. So first three lines you'll see is related to the tracing only. And in the initialize block, at the time of execution for the particular block, so it calls the initialize block, which is responsible for executing the particular block, right? Inside this, what we are doing first, we are checking the you can see here how it is going is like extract pre-digest, right? So what this function is doing is like it is picking all the digest, which is, we already have in our for example, in our storage or in our system. So this function here, we are just passing the header for the current block. So with the help of that header, we are just picking the pre-digest. So it is the consensus information, right? Like the digest information from the consensus for the runtime. So we are picking the digest. We are just storing that into the variable and initializing our block implementation, right? Here you'll see first we have called our initialize block function. Inside that, we have the implementation for it. In the implementation part, specifically what we are doing, firstly we will reset the events, then we'll check whether do we have runtime upgraded or not. Like this is the function is provide us whether, like from the last call to this call, if in between any runtime upgrade has happened, so we'll just it will return us the true, and we'll pick the weight to it and add that weight to the weight variable, right? So similarly, for the on initialize, like we are picking the like whatever the weight is being used for the on initialize or initialize function, will return that weight also after calling the initialize function. And similarly, we are just picking the base weight for the block initialization. We are all three, we are adding it and just registering the extra weight for the uncheck, right? So what this function is doing here is like it is just providing the weight, registering the weight, which is being which is used to be accounted for. So whatever the weights we'll be accounting, so we'll register that weight at the time of initialization only, and just calling the node finished initialization. So these functions at the end, just if you see that under the hood, so this is as per the definition, it is saying like it is to be called immediately after finishing the block initialization. So, and when we already talked about the runtime upgrade. So this is how we are just picking the, like it is returning whether true or false, whether the runtime was upgraded in between these two calls, right? Like whether execute block, the previous execute block, and this one. right? So we have already looked into this. So after the execute block, after the initialization in the execute, our next step is to, here it is, right? We'll do some initial checks. So we have initialized the block. Now we have some initial checks. And if we look into the initial checks, so what it is doing specifically, so we are picking the block header, and we are just asserting here whether the block number is greater than 0, and the parent, we are just checking it from the parent hash, right? We are picking the parent hash and just going back one step, and with asserting whether these are true or not. If both are same, then we are good, else we'll just throw an error here like parent hash should match. And similarly, we are just ensuring the inheritance are first or not, like using this function. And if not, then if this function gives us the error, then we'll just provide this one, right? So now the flow is going from the in the execute block is like, first we are executing the block, then we are executing the block. First we are initializing it, then we are doing some initial checks. After that, we are calling the executing our extrinsics, whatever the extrinsics we have present in the information, and the right, what information we have available for the extrinsics in the block, then we are just executing those. And we are calling this function execute extrinsic with bookkeeping, right? Similarly, after that, we are verifying it and the final checks. This final check is more important, like interesting part here in the whole entire block execution. In the final checks, you will see we have multiple asserts here, right? So what we are checking here at the end, we are just picking a new header. So new header is just, we are using this finalize function. We are just picking the information of the block, the entire block, and we will compare that with whatever information present in our current header, right? So firstly, we are checking check digest using this assert function. And after that, what we are doing, so this is the major part here. We are just calculating our digest. So whatever the digest we have, we have in the current header, and whatever we have in the new header. So new header is at the end, we are just picking the header like after removing the temporary fields, like, because in the at the time of execution, we are just populating some storages for the execution and all. So after removing everything, like entire storage and local information, I would say. So we are just picking up some major information like state root, right? Extrinsic information, some block counts and all. So this is what we are comparing here in the final checks. So this specific code talks about, like, we are just comparing the header item and the computed item. We are getting it from the new header, and we are checking whether those are equal or not. And we are also checking the state root also, state root of the header. So here you can see we are just comparing our state roots. So we'll see in the examples like how this is being, executed and how it is actually computing this, and when at which step we'll get error. Like if our state roots are, different for the blocks, so we'll panic here, we'll provide error here. And if our extrinsic roots are different, so we'll throw error here, right? So this is the final check in the block execution. So okay, so if I go back to the execute block function, so these are the just let me zoom out a little bit. So this is the flow for the execute block, and this is actually I would say here in the function, you can see this is our implementation for the execute block, and inside the execute block, we are calling this function, right? So this is the flow initialize. After that, if we talk about from source to the destination for a specific set of instructions. So first we are initializing, then we are checking some initial checks, then the signature verification, then the extrinsics execution, and at the end the final check. In the final check, we already talked about it, right? Now, if we talk about some other information, like Daniel already talked about, we have some functionalities related to the runtime upgrade, right? We can customize our code. So let me show you that. We already have that present in the documentation, how we can do that. If we directly go to in the frame executive, right? If we see, this is how we can customize our runtime on runtime upgrade code, right? And obviously Alexander already showed you guys some customized example over there. So we have a structure here. We in the structure we are just implementing our on runtime upgrade for the particular structure. Whatever information we need, we can put over here. We'll see this in the examples sections also. Like we already have a test cases, a set of test cases present with a whole runtime setup, right? And through this, we can just provide us the custom runtime upgrade type here, right? In our executive type. So this is how we execute this. And if we see, okay, so if we see how things are going, so we already have examples, a test case section present in the module. And okay, before that, we have some more functions in the executive module here. Like we already talked about these finalize on the final checks. Okay, now let's see what we have other. Okay, so apply extrinsics, right? So this function is being used when we are going to execute our extrinsics. So inside this, we are just picking some encoded and encoded lengths, and we are checking. We are just checking the checked extrinsic. This function gives us the checked extrinsic thing, and we are just noting it. We are getting the dispatch info of it, and we are just applying it, right? Here you can see we are providing the checked extrinsic over here in the apply function. So, and similarly, we are just doing some random piece of validation checks and all. So if we see the applicable apply function, this is a type of unsigned validator. So it execute all the necessary logic needed for the prior to dispatch and deconstruct into function call, right? So we can provide the implementation for this. This is the implementation for our testing piece. So I don't think we should go more into the more detail into this testing stuff. Let me show you the how flow is working in the testing. So on the same module, we have the module called tests. Inside test, you can see all the implementation, like how you can configure it for your environment and all. So we have some on initialize, on idle, finalize, and all. So inside this, let me show you. We have at the end we have provided the executive type in our runtime. So consider it okay here. So this is the type we have provided the runtime. We have provided some block like chain context runtime, all pallet with system. We already like Daniel already showed you so like some information about these things and the on custom on runtime upgrade, right? So now let's see when we are calling the execute block function for our execution and all, right? So let me show you the first test case for that, and then we'll see how it is going. Right. Okay. So this is the first test case we have, like block import works. So inside this, you can see here, we are providing the text externality and we are just providing the state root. So these state roots, both here, the state roots, these are pre-compiled and these are already being, noted after the compilation of the block. So every time you'll provide using these headers, if you compile the block, if you execute the block, always you'll get this state root, right? So when we hit this function, when we hit this test case, it will give us test case passed, right? And all the functions is being called on initialize, on idle, on finalize. This is what we have seen in the Alexander slide also. So now let me show you how it is different and how we can make some alteration over here. So we already know, like in the final check, which we have seen into the code, like we are doing some assertion over the state root, over the extrinsic root. So this is how we are doing at the time of final step, right? So the next test case is talking about like block import of bad state root failure. So because here we are providing the hard-coded state root, because this is what we are getting after the successful block execution. Now in this test case, we are just providing some random, right, default state root. We are just populating it with 0, and we know our state root will be getting our state root something like this from the block execution, because all the other information is same. Like we are providing the same parent hash, number is same, extrinsic root is same, right? If we see this, we already have provided the should panic here. Okay, now this test case is passed. And what error we are getting here, like hash is given this because this is the state root, right? We have given, and this is the expected. If we see in which line this is failed, in the final checks, let me show you. We are in the final checks function, and at the time of state roots, here our control is failing, right? Just give me a sec. Similarly, if we see any another, I would say the test case, for example, we have provided some invalid extrinsic root, right? So similarly, this test case is talking about the invalid extrinsic root. If we provide some invalid extrinsic root here, for example, we are providing the default one here. In this case, our control will fail on the at the time of extrinsic checks. In the final checks, let me show you. In this function, for that test case, our control will throw error from this assertion, because we'll not get the same extrinsic root which we have into the new header. So new header is all the finalized blocks information, and the current header, whatever the information we are providing to execute a specific block. All right, guys. So this is it from our end. Like maybe we can talk later on this stuff. If you can directly reach out to us from some medium and all. And like this is it for the learning session. Like let's sync up again next week with the new topic. And thank you all.